Okay, this is section 4.4, proving triangles congruent, looking at both side, 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 and side, angle, side. First, we're going to look at postulate 4.1, which is side, side, side congruence. And the postulate says if three sides of a triangle are congruent to three sides of a second triangle, then the triangles are congruent. So up here, we have two triangles. They have this side that's congruent, and these sides that are congruent, and these sides are congruent. Therefore, we have congruent triangles. And we're not going to look at a proof of these, a formal proof, but we are going to be looking at finding the distances of the three sides and seeing that they are the same, and thus proving we have triangles which are congruent that way. So we have these two triangles, and their vertices coordinates are listed, and we're going to use the distance formula to calculate the sides of our triangle. So the first side we are going to find its length of is WD, and for that we had the points -7, -4, and -5, -1. So we're going to take, let me see if I can write this with you still being able to see the points. -7 plus 5, that's squared, plus the y coordinates, so -4 plus 1 squared. That gives us -2 squared, which is 4, plus -4 plus 1 is -3 squared, which is 9. So this segment, WD, has a length of radical 13. Next, we'll look at segment DV and find its length. So here we have -5, -1, and this is -1, -2. So once again, using that distance formula, we'll have -5 plus 1 squared plus our -1 plus 2 squared. And here that is then -4 squared, which would be 16, and this side would be 1 squared, which would be 1. So we have radical 17 for segment DV. And I should have left more room, but for segment VW, which has coordinates of -1, -2, and -7, -4, we'll substitute those points into the distance formula. And we have -1 plus 7 squared plus -2 plus 4 squared. So this would be 6 squared, which would be 36, plus, and this is 2, and squaring that is 4, so 36 plus 4 is 40, radical 40. And radical 40 could be rewritten as radical 4 times radical 10, and therefore we have 2 radical 10 for our third side. Now we need to do that. I need to scooch this up a little bit, and I'm going to scooch it over also. So we have room here. We need to find the lengths of the segments of our third triangle, of our second triangle, I mean. And we'll start with ML. I'm assuming it looks like that is the side that's going to be congruent with our segment WD. ML, WD. So we have, get that here, ML is equal to radical, and our coordinates are what is that one? 1, -5, and 2, -1. Or no, we're doing this one here. So 4, -7 is M, and 1, -5 is L. So we're going to have 4 minus 1. Square that. Plus -7 plus 5. And working this out would give us 3, and squaring that is 9, plus -7 plus 5 is -2, squaring that is 4. So we have radical 13 for segment ML. And next we'll take a look at segment LP. LP corresponds to side DV. So we have our x coordinates of 1 and 2, and we'll square those, and then we'll add that to the y coordinates of -5 and a -1, so it's going to be -5 plus 1. Excuse me. And squaring that, extend my radical sign there. We have then 1 squared, which would be 1, plus -5 plus 1 is -4, squaring that is 16. So we have radical 17, so as far as it can go, and it matches up over here with side DV. Lastly, we have segment PM. So we'll get the distance formula radical sign in there, and we have P, which has coordinates of 2, -1, and M, which has coordinates of 4, -7. We'll substitute those in. So that gives us 4 minus 2, squaring that, plus -7 plus 1, squaring that. We have 2 squared, which is 4, plus our -6 squared, which is 36, which is radical 40, which we found out over here was 2 radical 10. We have 3 sides with the same lengths. We have congruent triangles. Please complete concept or check your progress number 2. Continuing on with this section, however, we have a couple of constructions in this section you'll see here, and then down here we're going to do those together in class, but we have a vocabulary term to talk about here before we move on to the constructions, and that is included angle. Now the included angle is an angle formed by 2 adjacent sides of a polygon. So if you look at our triangle over here, ABC, we have side AB and side AC, so those are our adjacent sides, and the included angle is angle A. We need this vocabulary term for our next postulate, postulate 4.2, which is side angle side, also written side or SAS. This states that if 2 sides and the included angle of one triangle, so this is 2 sides and the included angle of one triangle, are congruent to 2 sides and the included angle of a second triangle, then the triangles are congruent. So that's what this figure is illustrating. We're going to skip the proofs in the rest of this section, and as I said, we will do this construction of a triangle using 2 sides and the included angle, along with the earlier construction using side, 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 together in class.